Hi, we're going to go ahead and start, and I'm going to go into chi-squared of not equal proportion. So a manager for an insurance company believes that the customers have the following preferences for life insurance products. 20% prefer whole life, 30% prefer universal life, and 50% want life annuities. The result of the survey is 271 customers were tabulated. If the sales manager's claim refuted by the data at the alpha of 0.025. So here is all the numbers we get. Whole had 134, universal had 111, and annuities had 26. So with chi-squared, your hypotheses are always going to be the null is that the probabilities equal what you believe, and the alternative is that at least one of them is different or they're not how you believe. So when you look at that, it's B for this one that is not, that we would pick. That the null is the preferences for life insurance are as the manager believes. The alternative is that they're not as they believe. Okay, so the next one is you got to you got to pick which one of these is true. And we already knew in there that he believes the proportions or the probabilities are different for these problems. So your answer is B. Some of the categories are going to have different probabilities. And for step 3, you have to put what they are. So all I did is I converted those percentages into decimals. For 20% for whole life is now 0.20, and 30% is now 0.30 for universal. And then you can do annuities, and that's how you fill that in. So now you have to do the observed. So again, I made a table, and I put my observed in there. And now I want to look for my expected. So all I did is my N, which is my sample size, times the probability for each category is listed. So for whole, it's 271 times 0.20 gives me 54.2. Universal is the same, but the probability is 0.30 and annuity is 0.50. The sample size stays the same, but your expected values are going to be different. So that's where I'm getting these expected values. The expected values for whole life is 54.2. For universal now, it's 81.3. And then from there, I have to make my chi-squared. And remember, to get your chi-squared, you do your observed, which is 134 for whole, minus your expected, which is 54.2. And then you have to square that, and then you have to divide by the expected. And if you do that, you get 117.49. And you do all those for whole, universal, and annuities, and then you add them up to get your chi-squared value. So to save time, I went ahead and did that. So I get 216.83, which is 174.49 plus 10.85, plus 88.49. That's where this number comes from. It comes from your calculations. Again, if you have the calculator that has this function, go ahead and use it, and there's instructions in the book. All right, and that gives me my test statistic. Test statistics is 216.83. Now I have to find my degrees of freedom. I had 3 categories. I'm going to subtract that from 1 to get 2. The next step is to go into the table and find the critical value of the test statistic. Remember, you're using a 0.025 level of significance, and you go down to 2, and you get 7.378. All right, based on this, you've got to see if you're going to reject or not reject. So 216 is greater than or equal to 7, so this is true, so you reject your null. This rule is in 10.6 for you to look at. Okay, so look for that rule and you'll see what I'm talking about. All right. So if I reject my null, that means my alternative is correct. So it states the preferences for life insurance products are not as the manager believed. So what we're hearing now is that we did not get the 20%, 30%, or 50%. We don't know which one is different. We just know that one is different. So how do we conclude this? there is significant evidence to refute the manager's claim because we found out it wasn't true. So that's how you do a problem where your probabilities are different. I hope this helps.